Hi everyone, welcome to our data science, machine learning and AI course. Your first step towards mastering the AI skills and become an artificial intelligence expert. This module is all about Python introduction and Python fundamentals. Check out the full playlist in the description for everything we have covered so far and hit subscribe to stay updated with new lessons and future modules. Today we are going to learn about list in Python. List is a data structure in Python, and what a data structure is that it is a format in which a data is stored for us to work with that data in programming. So data structure, it sounds like there is a data and there is a structure, there is a format in which data is stored. In every programming language, there are different kinds of data structures. In Python, we have a very nice data structure called list. And what is a list? So let's start with the definition. List is an ordered mutable. Mutable is a term that is commonly used in Python for objects. And what does it mean is that modifiable. So there are some objects in Python that you can modify, and there are some which cannot. So mutable is that modifiable feature of the data structure. So list is an ordered, modifiable or mutable collection of items. It can contain elements of different data types, including other lists as well. Okay, that was the definition. Now let's start looking into it in the respect of coding. So for example, I initialize a variable named as x equal, and the syntax for the list is using these square brackets. So in our previous videos, we also have covered a little bit about list, but today this video is all about the list and the different methods and operations that you can perform on list. And list is collection of elements. What are the elements? Elements can be integers like 1, it can be float like 5.2, it can be a string like Abdul, or it can be a boolean value like true. So all of these values, they can be stored inside one list, and each one of them is called an element. So now if I execute this cell, remember that in order to execute a cell, we either press this play button in the Google Colab or we press Control Enter together, and the cell will start executing. So I'm just going to press Control Enter, the cell will run. I'm running this notebook first time. So yeah, the Google Colab is connecting, and after that it will start executing all the cells. So let's wait for that a few seconds more and it will start working. It's connecting. We will soon see that this cell would have executed. Now the cell has executed. We have this list stored in X. So if I want to print it, I will just write the print command and hit Control Enter, and this will be printed. So now you can see the list can contain all different types of variables like integer, float, string, boolean, and it is very easy to even iterate through lists. So how we can do that? In our previous videos, we learned about for loops. So what I'm going to do now, I'm going to write a for loop to check the data type of each element inside the list. So what I will do, I will say for each element. It is that much simple. For each element, in is a membership operator, we have learned about it, in a list called X. So I will say X, then I will put a colon, then press enter, and then now I will actually print type of each element. Along with that, what I can just do, I can just put a the value itself as well, like this. So we will print each element and the type of each element. Now let's hit enter, Control Enter. You can see 1 is an integer, 5.2 is a float, Abdul is a string, true is a boolean value. So list can contain elements of different data types. That's one example. Now lists can also contain other lists as well. For example, I can say new list is equal to like this, and then I'll just hit enter. I'll actually write something here, 1, 2, 3 and 4. Okay, remember one thing, it is a very good convention that when you write a comma, you leave a space after that and then write another value in the list to actually maintain this clear structure of the code for this. And also lists are collection of different elements separated by a comma enclosed in the square bracket. So that is just one thing that you can always remember about the data structure of the list. Now moving on, we just created one list inside another list, and here I can press enter and have another list called apple, grapes, and then we can even say oranges, and then I can even say uh, pineapple. Okay, we can even create another list for the prices of all of them. For example, 5.2, 3.6, 9.1, oh, it's 33.6. Okay, anything that we like, and then 5.4, etc. So there is a list containing multiple lists inside it. So a list can, and also it's not necessary that this list can contain each list of same size, which I'm going to tell you about now as well. So let's print the list first, this new list. Control enter. Now you can see it has printed the list. There is a very nice thing about Python, that it has some functions that work across a lot of data structures. One of them is called uh, length function, which you will see in many other data structures, and it is used as len. So what it is actually, we can check the length of any list. For example, let me check the length of x, and I will also print x as well, just to make sure what is inside the x. So see, I just printed the length of x, which I say len, then I put a bracket, I specify x, and then I close the bracket, and then I call the print function to print the length of x. And here I have also printed the x. So length actually tells us how many elements are inside the list. So this list contains 4 elements, so the length of the list is 4. Similarly, if we check the length of a new list which we just created up there and print it, it says the length of the new list is 3. Why? Because it only checks the length of the outer list, not the inner list if there are some additional lists inside the list. So we can also do something like this. We can just run for loop again. For each list in new list, print length of each list, and also we can print each list as well, just to understand what is happening. And yeah, let's enter, control enter. So what I did here is that I called each list present inside the new list that we created before, and I printed that, and I also measured the length of each one of them. Now it's not necessary right now. I just created an example where we have each list having the length of 4, but that's not a rule. List of lists can vary in length as well. So for example, I can just copy this one from here and create another list down here, call it new list 1, and I can remove this one from here, I can remove these 2 from here, and it will still be a valid list. I can print it in front of you. So you see, the first list is containing the 3 elements, the second list is containing 4 elements, and the third list inside the list is containing 2 elements. It's still a valid list. So that is all about list actually, that you can start to know about list first. And so the concept is clear. You know that list is a data structure in Python. The syntax of the list is that it uses these square brackets, and then each element in the list is separated by a comma. Now, and list can contain elements of different data types. You also know about this. We are going to learn more about the key operations of list now. And what are the key operations? We will see now. So one of the key operations that we always want to learn is that, for example, we have a retail store and we are keeping the inventory, okay, and key operations that we want to actually perform, key operations in list. So key operations in lists, and we have a retail store and we are measuring the inventory and recording the inventory, and we have a list inventory, and we have apples in inventory, and we have oranges in inventory. Okay. Now I want to tell you that I just received some grapes and we want to add them in the inventory. So first of all, this is our current inventory. I'll just print that. So our inventory contains apples and oranges. So inventory is a list with apples and oranges. Now if you want to add something to this list, like appending, how do we append? Python is such a nice language that everything is simple English, and if you want to add or append something to this list, it has the word append for it, function append for it. So what I will say inventory dot append. Append is a method. So the way you can call it is that you write the list variable where you have the previous list stored, and you write a dot to actually call the method or the function for the on the list, and then that much method is called append, and then whatever you want to append. So we received grapes and I am saying inventory dot append grapes, and then I want to print and check if my inventory list has been updated or not. See, once I have actually appended the list using this append function, it has added grapes in the list. Okay. Now sometimes you may receive another list for inventory. For example, that I just received a list of some vegetables, and I will just call it veg, and what vegetables I have? Potatoes, and then we have these onions, and I actually want to merge it into my inventory list. This is the list of vegetables, and my store manager just told me that I need to merge it into the inventory list. And how I can do? Either I actually append each of the vegetables in this list one by one, or I can use another operation of list which is called extend. So what you can do, you can extend this inventory to include this queue list into that as well. So this is how we can actually do it. So we will say inventory dot extend, and then we say veg, and then what I will do, I will print inventory again, and this time we will see yes. So previously we appended grapes to the inventory. Now we extended the inventory list with vegetables, potatoes, and onions list, and you can see that it has actually extended the list inventory. Similarly, sometimes you may also have to insert something in order. For example, as we saw in the beginning in the definition of list, that list is an ordered mutable collection of items. Whenever you hear the word ordered, it means that every item, every element in the list has a position, has a order, and that is what we call index. So for example, this apple is present in the first position. Indexing starts from 0 in Python. So please remember, indexing starts from 0 in Python, and so the first element in the list will be at position 0. The second element in the list will be at position 1. Okay, and so on. So if I say inventory 0, you expect to see what? Apple for it. I expect that it will show me apple, right? It showed me apple. And if I say inventory 4. Oh, sorry, I didn't type 4. It says onions. So you see, if we start 0 from here, 0 for apples, 1 for oranges, 2 for grapes, 3 for potatoes, and 4 for onions. So these are actually indexes or locations of elements inside the list. So you can also insert something in the order. For example, maybe you want to insert fruits in the same order where you see the fruits. So for example, I just received a request that please add a fruit, banana, in the inventory, but please add it along with fruits, so people actually working in the store can find fruits easily whatever are available. So I want to insert fruit, banana, right after the grapes. So uh, apple has an index of 0, oranges has an index of 1, grapes has an index of 2. So at index 3 I want to add banana. So what I will do actually, I will use a method called insert, and I will say inventory dot insert, and then I will write whatever the index where I want to add something, and then I want to write the value fruit that I want to add, banana, and then I will print inventory. Now you can see that banana has been added in the location 3 along with other fruits. So I specified the index where I actually want to add banana. That is also another operation that you can perform. Now there are some other operations that I just heard from for example, I just heard from my manager that oranges, we have run out of oranges in our store, and please update the inventory that we no longer have oranges, so that we don't accept any orders for that, and I want to remove oranges from the inventory. It has a very nice method called remove, that you can remove the presence of a value in the list by just calling the method remove, and I will say remove oranges, and then I will actually print inventory to check if oranges have been removed from the, see, oranges have been removed from the inventory. That is one way to remove. And sometimes uh, you can also remove something based on the index of that. So I just heard from another person in the store that we have run out of potatoes, and please, and I don't know exactly the spelling of the potatoes, or maybe and he just tells me please remove the item at index 3 from the inventory. So if I say removing the item for index 3 from the inventory, what I can say, inventory dot pop 3. Now see, index 3 is for potatoes, 0 for apples, index 1 for grapes, index 2 for banana, and index 3 for potatoes. So when I say inventory dot pop, it will actually remove any element stored at index 3 in the list. And there is one more good thing about this, that this pop method will also return the element that it has removed from the list. So I can say uh, returned element, print returned element, and then we can actually print inventory as well. Let's do it in this way. So you can see we removed the potatoes from index 3 in the inventory list, and then we have actually printed the updated inventory. So whenever we try to remove using pop method any value from the list, so what we did here, we tried to remove potatoes which were at index 3 in the inventory list, and when we did this operation, it told us that it has removed these potatoes by returning the value. We printed it and we have checked it was potatoes, and now finally our inventory is updated with apples, grapes, banana, and onions, and that was one of the things. Sometimes you also need to actually sort things alphabetically or in a order, and you really need the lists to be sorted. You cannot do it manually. So there is a very nice method in a list as well, that you can just call it on inventory, on list, and on our inventory list we will just call sort, and it will actually sort the inventory. But one thing that I want you to know, okay, let's do something first. After we do the sort, there are two things that you always have to remember. There are some functions which return a value, and there are some functions that actually perform this on the object itself without even returning anything. So let's do check what has happened first here. So if we print this inventory after running a sort, it was already like this. But if I actually add something here in this way to actually see what can be the result, so inventory dot append function we already have seen, and I'm actually going to append something called uh, kiwi, for example, and then I will print inventory. Now we have this thing. So now we can even try to actually uh, take the sort example, and sort also has a reverse true, so you can sort something in alphabetical order or in a reverse order as well. So if we say inventory dot sort, and so here you can even sort the list in ascending order and return none. So what it does, it actually sorts the list and return none, and it has this reverse function as well. So let's try the reverse function first, because previously our list was already sorted. So we say reverse equal true, and then we print inventory. Now you can see we have actually sorted this in a reverse order, and the same thing can be true if you just call the sort without reverse equal true, because the default value of the reverse is false. So inventory dot sort will just make it work like that, and we can print the inventory. Here you will see it has been sorted again. So that was another thing. Now sometimes you don't only need to sort something alpha in an alphabetical order, but sometimes you just want to reverse it. Whatever the order is there at the moment, you just want to reverse it. So that can also be very easy. So if something is not sorted but you just want to reverse the order, you can call the reverse method, and that is also very simple. Just write reverse, and every method that you have, it will reverse it in place. So what will happen, we will print the inventory, and you can see the list has been reversed. So there can be applications where you just need something to be reversed in the list immediately. And one last thing that is very important, that is slicing. Slicing is something that if you are working in Python, you will be constantly working with this thing. Either you are working with list right now, you work with the tuples or sets or arrays that we will cover later. Every time you will need slicing at some point when you want to actually get some information out of it, and for that we have this terminology that we specify the start index, end index, to actually slice something. So what really mean by slicing? For example, we already have this inventory list, and I want to slice the list from second index to the third index. So one example is like this: print inventory. So first of all, remember the syntax of slicing. You have a list and list object, and you specify the start index, then a colon, then a stop index. Okay, and stop index can be optional because if you do not specify the stop index, it will go to the end. And also remember, the stop index is not inclusive. So if you specify from 2 to 3, third index will not be included. We will see it as an example like this here. So you can see we started from index 2, onions have index 0, kiwi has index 1, grapes has index 2, banana has index 3. When I said do a slicing by specifying with a square bracket, inventory is our list, and here we have the square bracket, and then we have 2, the start index, then we have 3, which is the stop index, and then we printed the list. So I told you the last element that you specify at stop index is not inclusive into the final output. So if you want to include this banana here as well, you need to write it as 4 and then print it. So in another example, when we are doing slicing, we can specify the start index, and if we do not specify the end index, then it will continue to the end of the list. For example, if we do not specify this index 4, that is the stop index, and print the slicing, it will start slicing from grapes, which is at index 2, and then continue to the end. Now there is even negative indexing possible, but whenever we are performing the negative indexing, we actually start counting it from the right side. So onions have the index 0 when we are counting from left to the right, the indexing. But if we start counting the indexing in negative way from the right to left, then apples has an index of -1, and bananas -2, and then grapes -3, so on. So that is also useful when you want to take the reference from the end of the list rather than the beginning of the list. Both of things have their own advantages, and you can actually try this example here in a way that if I say -3 to minus, first of all let's call -1. If I say inventory -1, it will print apples. So let's see, and then from right to left, -1 is for apples, banana will have -2, grapes will have -3. So if I try -2, it should tell me that it is banana. And now if we want to perform the slicing, again for slicing you need to specify the start index first, which is smaller than the stop index, and this grapes has the negative index of -3, and then I can say my -3 up to -1, and then print. So what it will do, it will do the slicing starting from the grapes, banana, and again you know that the stop index is not included in the slice, so apples will not be included. That is another one way of doing the slicing, and you have seen all these operations, and I will see you in the next video where we will learn about tuples, and after that we will also learn about sets and dictionaries. So stay tuned. Till then, keep learning. Have a good day.